It's the shift from automation of manufacturing equipment to autonomy. Once we start seeing these autonomous factories, it follows that they will start being able to talk to each other. We suddenly discover we have a need for hundreds of thousands of ventilators. That shouldn't take 6 months, it should take 6 days. My name is Theo Saville. I'm co-founder and chief executive officer of CloudNC. CloudNC specializes in machining components, so we make pieces of metal and we send them to other manufacturers to assemble into products like aircraft or cars or satellites or consumer electronics or medical devices. All of these things rely on pieces of precision metal component. Today, machines are automatic in that if I want to make something, let's say this part for a robot, I can give a machine cutting instructions and it will follow those instructions over and over again. It will make thousands if we want. But the problem is, I had to make those instructions. So as soon as we want the machine to do something new, you need an incredibly expert human-machine programmer to get involved. Contrast that to autonomy, which is I tell the machine, make this for me, and it just knows how to make it faster and better and cheaper and more reliably than I ever could. We are making the entire journey from quoting a part through to making it, inspecting it, and shipping it out the door, end-to-end autonomous. So what I want to create here is a copy-pastable factory blueprint where you fire in your customer's 3D files at one end and you get finished parts out the other, and nobody made a decision in the middle. It's the shift from automation of manufacturing equipment to autonomy. And that shift is going to unlock what I call the end-to-end autonomous supply chain. Now, if we want to put a part like this in a CNC machine, there are hundreds of cutting tools in the machine. There are dozens of ways of holding the material. As you cut it, the harmonic vibrations change in the component. It is a combinatorial explosion of possibility compared to a 3D printer. So the problem is, how do I make this quickly and accurately when there's a trillion ways of doing it? There are all of these incredibly complex technical problems that stack on top of each other that you have to solve all of if you want to create the end-to-end autonomous factory. Once we start seeing these autonomous factories, it follows that they will start being able to talk to each other. We suddenly discover we have a need for hundreds of thousands of ventilators. We tried to, as an industry, build ventilators incredibly quickly, but it still took months to reconfigure the supply chain to make this new stuff. That shouldn't take 6 months, it should take 6 days. You can take the same process and make it output 10 or 100 times more than it could before. You say, I want a plane or a microwave or a satellite, and you call it from the assembly factory, and it just knows which factories to go to get those parts, which know how to make them. And so as soon as you've ordered your satellite, all the parts are already on their way through the supply chain. Something made pretty much instantly that would take years today, and the difference that's going to have in the efficiency of production, the carbon footprint of production, the speed of engineering innovation is going to be extraordinary. Solving that is a problem that I'm very happy to dedicate my life to.